Is going to give us the presentation for tonight, which is Cloud Vision API, limited preview. Let's go.
Okay.
Thank you.
Hi, I'm Emmanuel. I'm an engineer at Google. I do a bunch of things. This is one of them. So, have you guys heard about kind of what Cloud Vision is and stuff like that? Have you played with it? Are you even remotely interested about the talk? Okay, so you're interested, you don't really know what this is perfect, neither do I. However, the set of slides that we have here say, like it allows you to do powerful image analysis stuff. And then basically the key point here is it shows you, like given an image, it performs a set of vision tasks over it. Now, the idea we had was we have all this kind of vision-oriented technology inside Google. We use it in some of our products. These products have users, and they seem to like them. So how about we just make it available to people as a cloud service, right? That's kind of like what we started doing. So I know it sounds conceptually very simple. It almost was. So basically, the intent was, can we come up with a distilled set of features that people may like in sort of the vision domain and sort of offer them as a cloud service and then see like what the consumer feedback is. All right. So basically, can do image sentiment analysis, detect inappropriate content, and that's kind of across multiple verticals. Not only porn or not porn, but shows you it's a violent image, medical image, so on and so forth, text extraction, and a few other things. So basically, how about we just kind of close this guy and close this guy. You definitely care about this guy. So sort of what can you do? Well, let's see kind of like a hands-on example. Got it. Yeah. So basically, and hopefully it's still my passion. Okay, you definitely don't care about this, but let's see. There you go. Well, this one looks like it might work. So, bear with me just a little bit. I know I should have hit preloaded it. I'm sorry for wasting your time. Please ask me questions because I can do hopefully 2 things at a time.
Did you say this is going to be something that's available as a web service where you could submit a picture and then get a response?
Yes. Sort of things that people built with this. Here's more, and this definitely seems more used. So how about we do this thing here? Yeah, let's see what we get back.
Why no facial recognition?
So basically, this basically runs safe search annotations over an image. This is kind of the response, and then we can also look at the image. Hopefully it's fine. So sort of why no facial recognition? This is offered by Google, and I can sort of saying we can recognize faces across different pictures. It's a possibly sensitive topic. Therefore, we say we can do face detection,
Right.
which means given a face, we can figure out where the landmarks are in that particular face and then sort of show you the position and then do basic sentiment analysis. What we don't feel comfortable offering is a service that says, this is you when you're 20 years old, this is you when you're 30 years old, this is you when you're 40 years old, this is your grandfather very likely, and so on and so forth. Right? Because people may not,
They're going to get nervous.
they may not like that, right? So kind of that's why we keep it.
What's the spook?
The what, sorry?
Adult medical violence spook.
Kind of like it's an image that basically it's a sort of, they could think of Coma Puma, right? So sort of like you have a cat upside down. That's a play on an image. That's kind of what we believe to be a spoofy image, right? So it works sometimes. But let's just call the thing that. So this has been available as a preview for a set of kind of like people interested in it. But
Can
then,
you bring up an image? I mean, you're submitting images, but I didn't catch.
yes, I will. We will do the demo. I just have to figure out what JSON file I'm using and how to inject an image in it because it's not very well like rehearsed, if you want.
How many cores are you using?
For this, none. It's so efficient. I mean, it runs in the cloud.
Friends, I did this capacity planning.
You did capacity planning for various things that. Let's see whether this works. Oh, there you go. Like out file 2, not out file 1. All right. So this kind of is the output of an image and tells you, hey, what are things in this particular image? And then let's look at what the image is. So the image would be this one. Right? So we take this particular image. I was publicly accessible, so I used it. So basically, you look at this particular face. Okay? And then sort of this is, it gives you the bounding polys on the face, so like quite applicable to robotics, I believe. Tells you where the landmarks are, the 3 positional coordinates, and it has lots and lots and lots of landmarks. Now let's see whether we do a little bit of sentiment analysis as well. So sort of what we say is like the roll, the pan, the tilt of the image, so we run a little bit of analysis over that, but we also have, very unlikely he's not happy. His doesn't show sorrow, so maybe we can pick a different image.
Kind of sad.
He kind of looks sad, I guess.
He's nothing.
He's
He's very unlikely to do it.
It's very unlikely we got this right.
Maybe. We could try a different one. So let's see. So what else do we have here? JM1. Right. So let's see. Yes, that was. I tried to have an image that sort of I was trying to run safe search detection over, and that was what I was comfortable having on my computer. So, oh look, we also have this one. So basically, what we can do now is something a little bit different, which is the user interface. So so we
It's our kind of user interface.
So we
Exactly.
we aim for simplicity, and then basically sort of this is available as a service on cloud. Therefore, people can build their own clients. If you're saying, hey, what have people built with this? This is kind of one example, which is so I worked with him a while back, sort of kind of over the holiday period. So this I found like a pretty nice use case of the API, which is kind of, hey, look at a bunch of faces from news articles. And then this is, he did all of this, basically just used the API, and I used the query stream as like a very good load testing case. So this basically looks at pictures in news articles. This is great, I already got my shoes. And then he's plotting how happy are people in this particular areas in the world, right? So this is kind of what he did. So sort of has a crawler, goes over news articles, feeds them to this thing, we detect the faces, we look at how happy, how angry people are, and then he plots it on the map. Okay, so this is one little cute use case of the API. Something that you might find interesting, and while I prepare my document, you should probably watch this. Vision demo. Maybe I can show you this one. Oh, there you go. So, have you seen this at all?
Yep.
You have seen this, right?
I was sent out on the mailing list.
Oh, okay. So, everyone saw this?
No.
Do you want to see it, or? Okay.
Why didn't you bring her?
Look, I'm happily married. I have 2 kids. I'm okay. This is a good demo. So kind of this is one of the demos that kind of like uses a Raspberry Pi robot. Oh, this one.
The service enables developers to detect a broad sample of
That work?
from everyday objects to
I can do it.
practical use. The service is so easy to use. As one example of the use cases, you can can't have any Raspberry Pi robot like GoPiGo calling the Cloud Vision API directly. So the bot can send the images taken by its camera to the cloud and can get the analysis results in real time. It detects faces in the image along with the associated emotions. The Cloud Vision API is also able to detect entities within the image. Now, let's see how facial detection works. Cloud Vision detects faces on the picture and returns the
So which we saw on the
eyes,
previous face,
nose, and
essentially.
mouth. So, you can program the bot to follow the face. It also detects emotions such as joy, anger, surprise, and sorrow. So the bot can move towards smiling faces or avoid anger or surprised face. One of the very interesting features of Cloud Vision API is the entity detection. That means it detects any object you like. Let's see how it works.
It's glasses. It's banana.
So I'm gonna get an image where we run label detection because this is somewhat interesting.
You see, Cloud Vision lets developers to take advantage of Google's latest machine learning technologies quite easily. Please go to cloud.google.com/vision to learn more.
So yeah, I honestly believe the Bash sort of demo is better than this. Other people disagree. So if you want, we can try more examples on sort of that. And sort of to figure that one out, we can do here, so Vision Internal. And then sort of I will show you how you can quickly integrate something that is on the Google Cloud Storage with this particular thing. Why does that matter? If you have, so sort of like some of the things we do at Google are about scale. And some of the networks that we have trained behind all of these images are about sort of looking at or sort of training over large amounts of data. So we believe that if you want to run large-scale computations, people should have such a platform, okay? So Google Cloud is one option. And basically what this shows you is, well, I can have something stored here. Like on Google Cloud Storage in your project, you have this particular two images. This would be like Chuck Norris. Looks like this. So then let's see if like he's very unlikely unhappy or whatever the attribute was, okay? So let's see how, or I mean, Chuck Norris is never me. So let's see. Okay, so let's see. All right, there you go. I remember the name. So, this is going to melt down with Chuck Norris, I'm sure. Right? It's just going to segfault, I mean, flat out. So, I think the one thing that kind of is nice here is, and I think this is going to be present in our, well, I don't think, because I wrote it. So this will be present in our beta release, is this. All right. So I think that should work. Okay. Maybe. It is the Chuck Norris demo. So basically what this allows you is you can see what the request format looks like. So you say, I want to do a bunch of images. I want to have 100 results for face detection. And you can give it sort of a Google Cloud Storage link for the image that says, hey, this is essentially where my images are. But I don't understand something. So please bear with me. I know this, but you could ask me questions, and then I can try to answer them.
But how does it handle, do you have to upload your images to a server first, or can it?
So there are two modes for it. The first one that we did for alpha, I figured out it's easier for people if they embed the image content directly in the sort of request they make to the servers, because that keeps all the concerns about, oh, how is privacy ensured about my data? How are you protecting my images? Kind of moot because the server is pass-through. We don't log anything. We don't store anything. And we just basically return just sort of what we detected from the image. And it's essentially at the point that we responded to the request, the image is gone from the system. Right? So that mode was good to start with. But for practical things like I have to do 10 million, 100 million images or more, then like ingress bandwidth on the network starts to become a factor. So people are not, they would prefer a better solution. For that we say, hey, look, we can give you Google Cloud Storage as an option, and then you can essentially embed a link in that image. The API structure is pretty simple, which is, here's a group of images, and for each image I want a group of features to be analyzed, and for each feature, I want a group of results. This is kind of what this little thing here does. I'm not entirely sure why. Oh my God! Seriously, Emmanuel? Ah, there you go. At least it does something. I'm trying to figure, fine. So it's, again, getting there. So what do we say? Unlikely he's angry for the image. And then sort of these.
Yeah, wait a second. This is Chuck Norris.
This is Chuck Norris.
What a bad actor.
That's less than very unlikely.
Where's the
let's not focus on the negative. So let's see what it does this one. So basically what I changed there is label detection. So what does it say? What does it think this particular thing is about, right? So man, fair, hair, musician, athlete, hairstyle person, volcanic plug. That is a guitarist, profession, wrestler, beard, drummer. So some of them are kind of spot on, right? Especially kind of like actor, right? So that is the label detection for this particular image. Now let's see what else do I have in my amazing Google Cloud Storage.
We got some questions back here.
Sure, anytime, just ask.
Would you see like something other than people? Like vehicles, food?
Yes, that's exactly what I'm trying to figure out how to upload to my Google Drive using the amazing ecosystem, and then sort of run label detection over it.
Okay.
Right? That's the question. So how about this guy, right? I mean, this one should be reasonable, right? So
how about like detecting all the code cans in an image?
Yeah.
You mean like logo detection?
Or just object detection.
Object detection, separation, like the wine bottle
Sure.
with the red label versus
Right.
wine bottle with
So
the
one
label.
thing that we're going to do is,
That they're both wine
given a
bottles.
picture, we can say, hey, like these are the entities we detected, like banana, Coke can, money, glasses, whatever, right? So basically what we're going to do for each of these detected images, we are going to return bounding boxes, which I believe addresses your question, right? Okay, so
So the things you're detecting are things that are in, you have training sets for. Is it possible for the user to upload?
Right, so that's a fair question. So character, so OCR, sort of text detection is pretty standard. So there are some differentiating features in the API. Label detection essentially uses a neural net behind. Safe search uses neural net. And a lot of other things too. Now, some of these models are essentially evolutions of models that are already in the public domain for like kind of like image recognition. You have ImageNet competition, and then the sort of models submitted there are fairly public, right? And sort of if people want to train their own models, there is a framework that will allow them to do so on the Google Cloud servers. And then basically you get to run this particular thing through your trained models. Now this API that you're seeing here is inference only, because that sort of keeps the cost sort of predicted for what we run. And we're going to place it over to be like kind of high volume, meaning like I have many, many images and I send you not so many RPCs, and not very far in time, I will get back my results that hopefully some of them will be accurate. So that's, yes, there will be the possibility of kind of running the whole ecosystem, like training your own model and running inference, doing training and inference on cloud. This right now, inference only, based on things that we kind of train inside and things that are kind of exported in other Google products. All right, so would you guys like to see what this is about?
Yeah, this.
All right, fabulous.
Is there any throttling for your request?
Yes, there is. Yeah. So it looks pretty simple. Without going into the gritty details behind it, are servers that kind of like look at sort of incoming quota, offending RPCs or offending clients, consumer projects. They establish quotas based on like features. So sort of like there's a usage manager that says, given this particular client project, how many label detections they have used, how many face detection they have used, and so on and so forth, detects against spikes, the whole thing. Why we also do that is some of these features are more computationally intensive than others. Therefore, they will have a different SKU, like a different price for what we do. And I mean, it costs us more to run, and maybe people are interested in them, so maybe they'll pay more than features that are cheaper and will be priced. So yes, so we do everything from kind of protecting against influx of QPS and detecting offending clients and API abuse, all the way to sort of offering a different pricing scheme. I can't tell you too much about it because I don't really know it, but they're computationally different, therefore that makes sense. I think that's what we're doing.
I have a quick question. Do you have any sort of accuracy figures for your road pitch yaw detection, especially for faces, essentially?
Right, so like there's some, yes, this is fairly, so they're offered as likelihoods, right? So now, whenever you give a float like this float here,
like a validation set or something.
Right. So
how much are you getting?
yeah. So essentially, whenever you give a float as part of an API, that kind of limits your flexibility in updating the models behind it, because people will obsess what does a variance in the third digit mean. So then you have to explain, for this particular label that doesn't really mean much. For this other label it means this, right? So that's why we kind of went with the possibly silly looking names for the buckets, which is very unlikely or very likely he's angry or this is porn, because that keeps sort of model upgrades in the background stable across number of releases, right? So the scores we have are sort of indicative of what we can do, but just having full precision scores doesn't really mean much anyways. Like typically from what I saw, if you use more than 10 levels, probably something is up, right? So we offer.
You have TensorFlow on the back end, right? Specifically for the pose estimation.
So TensorFlow, you can use it for training and inference.
I know, but that's what you're using for inference as well.
That's a very bold statement, maybe. Maybe some of the models use TensorFlow in the background, but there are many, many models involved in just processing.
I'm talking particularly about this estimation of voltage of the phase from a single digit.
Right. I don't think that's what it uses, but I can double check, and if you give me your email address, maybe I can send it.
Sure, thank you.
Sure. Okay, so basically, let's see what the Van Gogh image does. If I can face it here. How bored are you with this? I'm sorry. It's like pretty disconnected talk.
Very unlikely.
Very unlikely. Thank you.
Take a selfie.
I will find one that works.
Score 0.2051.
All right, so label detection over this. Please don't tell me deadline exceeded again. It did not exceed deadlines. Probably when it creates the stops. Fine. So painting. Modern art, flower, artwork, window, glass. Okay? And now let's try something.
Now, can you give it a hint, like famous, like paintings, if you give it a hint, and then will it try to do an identification of a specific famous painting?
Right. So if you look at those kind of like myths there, what they're trying to do is take the free-form text and map it into a concept or like a category, taxonomy, hierarchy. So basically collections and entities. That's free-based.
Yeah.
So basically that particular ID maps to the collection. Now each of them has a score, and we do return results sorted by the score, meaning like the higher scoring ones are what we believe to be more descriptive of this picture. Can you tell it, hey, this is mostly about flowers? Currently not.
Yeah.
But you could say I want 100 results and like pick the flowers up. Will that change the result of the inference if you give additional hints? It will. Right? So like you could probably get higher detection results if you do it. So label detection. Let's say landmark. All right, so this is what it tells you, right? It's Museum of Modern Art, right? It just looks at it and it knows where it is. Also gives you GPS coordinates for it. Now, I think this is rather cool. Very likely it's cool. I'm still thinking about well, kind of that's what it is. Sort of like gives you the sort of bounding box for this thing, and then it also gives you like a lat long there. And I'm not sure if I can tell you how we figure out where it's located on the map. But
You combine it with Android and locate people. I know it's
Yellen, I think we worked together for like a bunch of years, and like I kept nagging you about getting resources and not thinking things, which panned out for record. So I'm not sure what we're using for that. Okay, so.
Is Chuck Norris in Landmark?
You know what? Why not? Let me see. All right. So we did label detection for him. We could try to do text detection. He should be. So that is the right answer. But let's see.
I have icon detection.
I mean, I hope he doesn't mind. Like it was a public picture. Like who knows? Like. But
yeah, because they'd be in the back of the room.
So did not detect any landmarks. Let's just try again. No, did not detect any landmarks. Other things we can try over the image are safe search.
Is it not deterministic? Like you have to try multiple times?
It should be pretty stable, should be deterministic. Sometimes when you give it a GCS link, it times out, and I think I know why that is. I think it's on the stop creation, and yes, it's going to be fixed. It also gets this one QPS, this one query on that target, so it's like kind of not all the connections are open now. And it's pretty aggressive at scavenging. So,
especially not Chuck Norris.
Sure.
What's the turnaround time per image? Like frames per whatever minute or per second?
So single digit seconds, 99.5, 99.9 percentile is what we try to get. Right. The math changes a bit depending on the image size. Typically, images that are larger than 1 meg, they don't get much benefit from running them, and just sort of induce a lot of stress on the system and the network, and sort of drive up the price for the ingress bandwidth. So images that are around 1 megabyte in size or lower, they actually work across all the models we have. So for things that are embedded in the request, it might take slightly longer than for things that are sent from GCS, because those are essentially in our network, and there the sort of network links are pretty good.
Can you adjust how exhaustive the algorithm is to make it go faster or slower?
If you're from the client side,
yeah.
So can you say run something really crappy but really quickly, or run something think harder? So we've right. So I think historically we've been shying away from giving people a think harder button on web search, which is where I spend a lot of my time working, just because you should think equally hard for all the queries. Right. Now, if somehow this, so sort of like every single query that the user asks you, you should do the best possible thing you can as a system, and that's what we're aiming. And if it's a question about folks want to send more traffic to this particular endpoint, then we should probably provision it correctly. Now, famous last words, you never know what the user is. It becomes a very demanding feature. Technically, it is possible. Product-wise, but it makes sense, right? Approximation always like saves resources, and sometimes it's good enough. I mean, that's how I write my code. Okay, so let's see what else we can do. So we can do text detection, did not detect anything. We can do safe search detection, which is, hey, is this particular image medical, violent, or porn? So, by the way, you can specify all of them in one request, but this is kind of the limit of editing I have on this particular laptop with this particular keyboard. So if you don't mind, we're just going to do them one by one. But you can specify multiple things, right? So unlikely violence, clearly. So it's Chuck Norris. The rest are very unlikely. This one is unlikely. Okay? So sort of, you said, hey, can we do like a different thing? So let's upload files.
Can it do stance or body language sentiment?
So you mean like sentiment analysis based on body language?
I mean like door camera. Can I get a response back on the various person at my door?
You could definitely get a response back of an angry person, very likely at your door. I wouldn't know how to sort of, yes. But sort of menacing pose versus non-menacing pose is technically possible.
So in the YouTube demo, they had like different objects being detected as part of the loop for where the robot would move. Is that a realistic thing that just a person in this room without too much funds would be able to like send you an image every 5 seconds for a day, or is that?
So you're asking me what are the API quotas, right? So in Alpha now, I think we're fairly generous. I think we have 10 QPS or 20 QPS at peak per client. And I think beta we're going to provision accordingly. So yes, we are expecting large queries per client. And we are budgeting to do that. There will be, I believe, a free tier in the sort of category of clients, but that limits like how many images you can analyze on the freebie plan. Yes, just please ask me questions because like I'm always like confused, so like I don't see the hands.
A big image with lots of objects, are you guaranteed to get the same results if you split it up and don't cut off any of the objects and do multiple calls versus a single call with a giant number?
Right. So some of the internal models do that. Now, how does it vary whether you present it like pre-split versus like if we run splitting over it? That I can't tell you because I haven't run a data set ready to do like a head-to-head comparison. Some of the objects do, some of the models actually will do that. Right? I mean, I hope I'm not mistaking reality, but I think it should be. So desktop, let's see desktop. This is not it. How do we go to images? Where are my images? Oh, I know what happened here. Very bad thing happened.
How much does resolution affect the result?
The what? The resolution
of the image, because some of those you pick large resolution.
Let's see. Look, my favorite web search query, flowers. Okay. So images. Okay. Now let's pick one with flowers here, like the smaller resolution. Maybe this. It was work or.
The butterfly, we'll find that.
Likely.
Likely? Let's pick.
I mean, like that little robot. What if I asked like the little robot in the demo? I'm only going to be uploading like pretty low resolution, like 640 by 480 or
right.
something. But some of the images you showed, at least the cursor was indicating they were like 2,000 by 2,000 pixels.
So you try to keep it a negative below that size,
yeah.
So that kind of tells you it's going to be small.
Yeah. So it's small.
Little camera.
So you saw that the robot was working pretty well, I would say. That camera was not very high resolution.
Yeah.
So for face detection, facial attributes, it works reasonably well. You know, it varies with like lighting conditions. It varies with like sort of ambient conditions quite a bit. For that particular setup, it worked well. Now, if it's dark and the sort of image is not very high resolution, it will be slightly more difficult. Yes. Good. So let's see how this works. I'm sorry, bear with me. Maybe I can figure it out now. No, what? I mean, this is the worst presentation you guys saw, so I really apologize for it. But I honestly believe what it does is pretty good. So let's see. Let's try that again.
A lot of us are new, so it's also the best presentation we've seen.
You are very kind. Thank you. I don't understand why it doesn't save images. That's not TV flowers. Simpler to remember that way. Okay, and then we go here, and then we do the Oblo files, and then we do the flowers. Excellent. This one, open. Woohoo! Technology. And we close this little box here, and this is 185K, right? So we had Chuck Norris was 50K image, worked fairly well. He was unlikely angry. The other one was 1.84 megs because essentially I was trying to see, hey, if they're pushing the limit over the 2 megs, will admission control kick back correctly? And it does, and this one passes. And then flowers is somewhere in the middle, okay? So here we have to do this, edit permissions. And let's say we want to do this guy, Control-C, do work here. Edit permissions, and let's say add item, let's say it's a user, it's this, say, very easy, it's like just 15 clicks. So then basically, 15 short clicks. 15 short clicks, all right, so then we go here, and what do we do?
What file formats are accepted?
I guess we'll see. I mean, this is a PNG, JPEG port. Let's see. Will this work? The line exceeded, let me guess. Oh no, very unlikely all of them because I was still on safe search detection. So would you like to run label detection over this thing? I think so. Yeah. Yes, okay. So as you can see, this is very unlikely to be violent or medical or label.
Does it take into consideration the file name?
No, not really. All right, so it kind of does these things. Cut flowers, orange, floristry, flower bouquet. Actually, for some of them, it does, right? But the vocabulary is not very rich.
Why did it pick person?
85%.
Flower child?
Flower design, plant. You know what? You see lots of people holding flower bouquets. It's an association in my way. Right? I think if we pick a very different flower, we're not going to get the same association. So there was another question about logo detection, right? I mean, do you still have time? Yeah. You want to go home? You're tired? Do you want to do something?
Just a little more.
Okay, I mean, okay. So let's figure out something that does kind of like logo detection, right? So what's your...
There's something in the upper left that looks kind of familiar.
Oh, you mean this one? Sure. Google logo. Yes, and I believe this one I can use. So...
Like in front of the Google office.
Come on, everybody always does Coke cans and robots, which is all.
Yeah.
All right, so we can try this. Let's see what it does.
So
All right,
do
so
a picture from like real life, where like there's a Google logo in a picture.
A street view?
Physical setting.
Sure.
Google
with some transformation.
Android logo.
Is it? Actually, we get to it, is it possible to get like a
how about this guy?
Yeah.
Sound good?
Yeah.
Save images. That's not work.
Don't give it away. Don't call it Google logo.
Apple logo. I don't come up with the names. So this, and then we do, what do we do? File.
I think it was only 12 clicks, right?
No, look, they're actually like, it's a web search. Thank you for searching, and it makes this possible. And then it's here, 103K, and boom. So let's do label detection over this thing.
You need permissions.
Oh, I'm sorry. Yeah, I need permissions. Yes, thank you very much. I was too focused on like running it and seeing what it does. Added permissions. I don't remember the address.
That's the Banjo one.
No, it's fine. I need to go here and then say edit permissions, and then I had to say add item, and I need to say it's a user and has a read role, which is fine. And I had save, and then basically we say now it should work. So GHQ JPEG. GHQ JPEG. All right, so let's see what this does. Shopping mall, excellent. Facade, convention, headquarters, plaza, real estate, architecture. These are the label annotations. Landmark.
Now name the file.
So you want to do landmark?
But
Okay.
that was a rendering of a
Name the
building
file
that
Google
was under
How do we
construction.
detect like where the objects are in that image? Like we want to detect where the location of bananas or whatever.
So if you
Like get the bounding box.
like find the front door.
Yes. So it tells you which objects are in the image currently. This particular DNS target doesn't give you the bounding boxes around them. That's something we're going to add pretty soon.
So it's not going to be able to, like, if you have an apple and a banana on the table and you want the robot to go to the apple, it will or won't be able to figure out, or will just come back with true.
With bounding boxes, it will be able to figure it out.
How do we even get the categories of things it thinks were in that image?
The categories, they map to freebase IDs. So sort of that's kind of like the namespace.
Right. But I mean, just the list of things, did it have a tree in there? Did it find trees and stuff like that, objects within that image? Is that what we saw already? Where
Is there a taxonomy?
Oh, the taxonomy, it's like freebase, right? So like the mid there encodes the type. So like there is a free system where you take that type and it tells you this is the category of this particular item, right? So then you can traverse collections and figure out which one of it is. If it's a tree of this stuff. Right, so these are just the free form strings. So let's see here, logo detection, right?
How about text?
Sure.
When it does object detection, does the size of the object matter? Like if you have a shot, a close-up shot of a banana, will it process that different than a far-away shot of a banana?
Yeah, the scale of the banana.
Yeah.
The scale of the,
Like does it shift into a landscape mode versus an object mode?
I believe so. I don't know much about that particular module, but I believe it will do that. But I don't want to tell you something that's not true. I believe so. I'm also very optimistic. So I'll just go home, run 2 test images, and see what it does. And I guess you can also sign up for the alpha. There's a link there. And then if you're curious about playing with it and seeing what it does, sign up for it. And I will most likely, I will be the one whitelisting the account, if not somebody else. There are all of like 2 or 3 people working on it. So if you like to give it a spin, don't hesitate. Sorry.
Very good. Sure. And that is, could you send the link to the alpha?
Yes, it's on cloud.google.com/vision.
Cloudgoogle.com/vision. Okay.
Just to see logo, because it was like a highly Google TV. I mean, sure.
Okay, thank you. Thank you. I just wanted to make it easy for people to find. Okay. And thank you very much, man. That was
okay.